Section 2.3, product and quotient rules in higher ordered derivatives.
Okay.
But before the higher order derivatives, just a hint, that'll be tomorrow. If you get somewhere in homework where it says something about acceleration, just tap out and be like, no, not yet. But that's at the end of homework. To get to product and quotient rules, I said this is an intro problem. Intro problem meaning, have you learned, it was in your summer packet, have you mastered the product rule yet? No. Have you seen from me in class our textbook the product rule yet? No. How would you solve the derivative of this function? Why derivative? Because what does this mean?
Derive.
Take the derivative, or the shortened way, derive, right? Derive him. How would you have to do, or how would you proceed, or have to proceed in order to use just the basic rules? Power rule, constant multiple rule, constant rule, sum and difference rule. How would you have to proceed in order to start this problem? Noah?
Or you could move the denominator. Oh wait, that's a multiplication. You could take the derivative of each side.
You have to multiply them out.
Sadly, we do not yet have a product rule. We have a sum and difference rule that says if two functions are separated by a plus or a minus, we can take the derivative of each. True? Derivative of f of x plus g of x is?
C of x.
No. Derivative of f of x plus derivative of g of x, which is f prime plus g prime. That's legal. Times? Mm-mm. But what do you think the most common mistake is that kids make with products? It's exactly what Noah just said. That's totally illegal. The only way to use the old rules is to somehow undo the multiplication if possible. How do I undo the multiplication? Distribute, go. Rewrite before you can ever derive. You cannot take a derivative using the basic rules without the newer rule that we're going to learn soon. You cannot take the derivative as it is. You must rewrite, and you must rewrite by distributing. Go. Get me a sum or difference, or a sum and difference. Get rid of that multiplication. Then derive. Yes, there's a BC problem on the board. You might not understand all of it, but what do you understand? M is slope. M is the normal. What? That's perpendicular. Who are these? Derivatives. Okay, go back. Shh. Don't look at the rest. That's for later. We're doing something called implicit differentiation. Snazzy. Rewrite by distributing, then derive. Rewrite, then derive. All done?
I feel like you're making us do this and we're gonna get it wrong.
All right. You guys have 30 seconds. Check with your groups and see if they agree with either how far you have gotten or the answer you've received. Go.
X to the third minus x squared.
Good job.
2x squared minus 2x minus 2. I multiplied this times this,
Minus 15.
and then I just spaced it out, and then I merged it all together, and then I took the derivative of this. Not the product one, power rule.
Is that what happened when you distributed and simplified?
Yes.
Is that the derivative?
No.
I haven't done anything. I haven't done any deriving. I haven't done any product rules. I wasn't allowed to. Product rules, sorry. Derivative rules. But now what can I do since they're just separated by minuses and pluses? I can derive it. How? Can I factor that? Sure. Let's review since some of you the basic stuff is hard. When there's a number in front, we look at factors of the first times the last. Factors of 39, 1 and 39, factors of 39, 3 and 13. That's all we got. That's all she wrote. Maybe you understand that analogy, maybe you don't. But anyway, so sad.
Good job.
Can either of these make 2? No. So therefore, can we factor? No. But good thing we at least reviewed if we needed to. Dun, 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 dun.
Dun, dun.
Did we need any sort of product rule to solve for this derivative? No. What did we have to do first, though? Polynomial multiplication, a binomial times a trinomial, and I had to distribute, and then distribute, and then combine like terms. I kind of cheated and did it fast, and then take a derivative. Carla.
Why didn't you have to use a product rule for it?
I didn't have to because we rewrote first by basically multiplying everything out so that there is no product remaining.
So how do you know which one?
Technically, this isn't wrong, but we're going to see it with the product rule soon, and you can debate as to whether you would rather do the polynomial multiplication then derive with this type of example, or whether you would like the product rule better. Because some people were like, ugh, I'm going to make mistakes, and some people did. But not every function can be rewritten. Not every product can be broken down. Like, what would we do with him? Distribute. No. Why not? You're killing something. I don't even know what, something endangered, but you're killing it.
Ostriches.
Ostriches? Anyway,
Whales.
you can't have a baby elephant or a baby whale. Well, I guess you can. That's not.
You can have a baby.
You can have a baby anything.
I choose
But-
baby elephant. Let's call him baby elephant.
But what would the mistake be?
Killing an animal.
Doing both.
If you said 2x cosine, I'm done.
Oh, it's because you
So
don't-
false.
You don't mess with the thing in front of the sign.
And you can't bring an x squared in to a sign. Sine of x is his own deal, right? That x is attached. That x is spoken for. That x cannot be combined with other random variables just chilling out there, right? Noah?
It'd be 2x cosine.
No.
No way.
No. 2x cosine is illegal. So here's the long story short. Can you take some products and make them sum and differences? Yeah. And then derive using old-fashioned stuff. But are some products stuck? Yes. So how do we deal with both of them technically? One, it's an option, and one, it's the only possibility. We use something called the product rule. And you guys saw it in your summer packet for a little bit, but did you master it? No. No. Maybe just a few of you seeing it in the summer packet is enough to master, but that would be the very, 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 very small percentage. You saw it in a quick slideshow. You might have been able to use it in an example. You might have just copied the person who was doing the little slideshow. But we're going to master it now. In the summer packet, technically it was written a different way. I started changing, I think it was last year. Last year was the first year I changed how I wrote this down, but it means the same thing, and I'll show it to you in just a second as to how it compares to the summer packet. I say the derivative of the product is the second function times the derivative of the first function plus the first function times the derivative of the second. Ugh, well that just was a whole mouthful. The second function times the derivative of the first function plus the first function times the derivative of the second. Or second d first plus first d second. Wait, what? Second function. D first, D standing for derivative of second d first plus first d second. Second d first plus first d second. However, for some of you, it's going to be a lot more helpful if we can visualize this without the messy f's and g's. Especially because in homework, quite frequently they give you the function f of x equals, and then the equals has a product, and then you're like, oh, there are two f's, and I just get confused. So the other way of visualizing it is with boxes and triangles. We put the first function in a box, the second function in a triangle. If we really were having fun, maybe a third function would be in a circle. That'd be fun. The operation in between them is multiplication, hence why it's called the product rule. And the notation for the exact same formula would be keep the triangle, keep the second completely the same, and then multiply by, oh, the orientation is off, that's rough. Multiply by the derivative of the first. That way you don't have to necessarily call one F and call another G. You can just be like, whatever's in the box spot, whatever's in the triangle spot. So second D first plus, what comes next? First D second. And when I don't say anything in between, I am implying multiplication, just like we always do every time we say something like a constant x. We mean multiplication. So then in words, how would I state this? The way I have been stating it, right? Second, D first means derivative of the first plus first D, or derivative of the second. Now technically there can be three things multiplied together, so then there would be like a first and a second and a third, and we would have to do all the different possible combinations to where only one is being primed every time. But this is the long story short. This is the most basic version of the product rule. Oh, and he's crooked. It's because I'm too tall. Is that better? Or is that worse? Oh.
That's better.
Better-ish. How did the summer packet show the product rule? And maybe none of you remember, and that's totally fine, and it's not going to be a problem. However, it did write it a little differently. Does anybody remember how the summer packet went? Carla?
I think it started with switched.
It was switched. It said F prime G plus G prime F. Now, hold on, pause. What you know about math, multiplication, does it matter which one really comes first? No. Why am I making a big deal about second D first plus first D second, and why am I not having it the other way? Sometimes when you go to take the derivative of the first, and similarly the derivative of the second, this is going to take a little bit of work. And sometimes you're just going to get so focused on this derivative that if it was first, you'd be like, whew, I finally got that plus. And you would totally forget about the g of x that needs to be in there. So the reason why I switched it around is so that automatically you put in the easy one, you're just going to rewrite him. You're not going to change him at all. Rewrite him times, do your derivative work. Hopefully then you're like, wait, product rule plus, there's a whole nother part. Put in the easy part, take some time with the derivative, and that way hopefully you don't forget as much as you might have otherwise. Noah, go ahead quick.
What if there's a third one in there? Like, how would you?
Basically, I don't want to write it right here, but I can. Basically, if you were to have a third one, what you could do in essence with taking your derivative is think about it as box triangle. Portion it off. So you could have the derivative of, second, D first. And the derivative of the first would be second, D first, plus first, D second. So you would have to do the product rule for him, but then you still have second D first plus, and you would have your f of x first, D second. And in essence, what you end up getting is f prime times the other two plus g prime times the other two plus h prime times the other two. So it's kind of similar with polynomial distribution. We just have to follow the same idea. One prime with the other plus the other prime with the one. Every time one of them gets primed and it gets multiplied by all the rest. So we could technically generalize that rule to be 4 things multiplied together, 5, 6, etc. But usually you see 2 every now and then 3. And that's about as hard as they can get. Okay, get rid of him, get rid of him. Good question. Hey kiddos, didn't we have a problem a second ago that we couldn't solve any other? Okay, so just a second ago, we were talking about this problem and we were stuck because we couldn't do anything to undo the multiplication. Do you guys now see the box and see the triangle, or see the first and see the second? Sweet. There is no rewriting. We just have to go. But the only legal way to go is product rule. And product rule says, tell me in words and I'll show it in math. Second. In a simple way. D first. Huh? His prime. 2x. Plus, first, D second. Derivative of triangle? Oh, it's not too bad. But pause, is it the same thing as? Take the derivative, bam. No. But what do you think? You know, from those chapter 1 tests we got back yesterday, they put the multiple choice answers to trick you. What would be a multiple choice answer? 2x cosine x. Why? Because they want to see, do you know the product rule? Yeah? Don't let them trick you. Equals. And similarly, don't let me trick you because I have to act like them. True? Not entirely like them, but getting you ready. Okay, that's good. Just a few of you were like, but wait, don't we have to factor? Stick it to the man, huh? But, if it was a matching problem, and you saw something with an x factored out, should you be able to say, it's the same thing, I got it? Okay, just keeping track. Wasn't there another problem that we did that was a product, but then we made it like sums and differences and like cheated and used basic rules? Let's see if it works the same way, and we'll get the same answer if we use the product rule instead. So let's go back to that very first example that you saw. Let's not break it down. Let's not multiply it out. Let's say that we have a first times a second. Then let's go. You guys practice on your own. Think about the rules. Don't rewrite. Go. Legally. With the product rule. Do you see why we had to get really good at shorter derivatives? Because in the product rule, you have to take the derivative really fast of individual parts. Ready? Check with your group, 30 seconds. You might not be done, but did you go the same way they did? And are you headed the right direction? You don't always have to wait until the end result. Sometimes you should check yourself a little bit earlier.
For like the ones with proof, would we be able to use like this chain rule, or is that for like only for composite?
Chain rule is only for composite, so if it was an f of g, but since just the x alone was in sign, and since x squared was separate being multiplied, it doesn't apply yet. But if the x squared was inside sign, then we'd have to go. Welcome. What'd you guys get?
1.
1. Why? The derivative of x is 1. The derivative of 3 is 0. 1 minus 0 is 1. Plus, first, the second. What'd you get for the derivative of the second? 2x plus 2. The derivative of 7 is 0. Poof. Stick it to the man. Maybe. I can promise if it was multiple choice, it's not going to look like that. So what do you need to do? Plus, we want to check it to our original answer, kind of like you guys in homework when you're checking with the back of the book. Could you always leave all of your answers in their nastiest, most unsimplified forms? Yes. But how do you know if you're ever right? Use the back of the book as a make it match opportunity to go ahead and see if you can make your answers match. Anyway, we have another answer to this. Let's make it match. Anything times 1 just stays itself. The second one, how do we legally multiply x minus 3 times 2x plus 2?
2x
We have to FOIL, right?
6x
Minus 6. Then we combine stuff, yeah? So f prime of x is equal to, I have a 1x squared, a 3x squared, those are now gone. I have a positive 2x, a positive 2x, that's 4x minus 6x is a negative 2x, and 7 minus 6, negative 7 minus 6. How does this compare to what we got at the beginning? Same thing. What's the difference? Well, one, you got to have fun and do all sorts of like distributing, multiplication, then an easy derivative. This one said, whatever, take it the way it is, piece by piece, and you still have to distribute a little bit, but not like the binomial times a trinomial, and combine like terms. Do we really want to make an argument as to which one's easier? No, the point is they both work. But, was there any other option, once again, for that one? No other option, had to use the product rule. So you guys tell me, how many different ways are there, of finding this derivative? Why just one? I can't distribute. I can't get rid of that multiplication. I'm stuck with it. So if you're stuck with it, what rule had you better go to whenever you see a product? Oh, go. How do you start from the beginning? Who's the first? Who's the second? Use the rule. But if you want, could you rewrite just a little bit first? Maybe not a bad idea if you're not so good at the whole square rooty thing yet. Because he's really just a fractional power. Now go. Did you get the unsimplified version? Yeah. Let me check. If you didn't, do you understand why it is what it is? Second stays the same. D first, bring down the 1/2. Subtract 1. Hopefully we're getting into that. 1/2 minus 1 is negative 1/2. That's a nice little quick fact to have stored away. Second D first plus first stays the same. D second. Wait, what? Derivative of e to the x is? You like him, remember? So then coming back. That's not going to match with any multiple choice answer that's going to be there, I can almost guarantee you. So how do we rewrite this puppy?
So, 2 square root of x.
Does the first part, there's a plus, I'm not done yet, does the first part make sense? 2 is in the denominator, he stays in the denominator. A negative power moves x to the 1/2 down, and x to the 1/2 is who? Root x. Plus, e to the x, root x. Yeah. Box it and you're done. Maybe. But what else could they do? If they so desired. And you would be able to tell because all of the answers would be in a single fraction, not a sum, with a common denominator. Ah! They wouldn't. They would. Do they always? No, not necessarily. But could they? Oh, yeah. And then you would have e to the x plus 2 e to the x times root x is just single x. And it's all over a common denominator of 2 root x. Oh my goodness, and there are 2 e to the x's just chilling. We have to factor that out. Maybe. I don't know. Depends on how they're feeling. Just saying. This one's right. That one's right. That one's right. That one's right. Oh no. Could making it match become complicated? Yes. Why is this a dilemma? Because in chapter 1 test, some of us had issues making it match with the right answer. This time we have a right answer. We just need to make it match with an equivalent form of the right answer. So we have to know our stuff, we have to be able to solve our stuff, and we have to be able to make our stuff match. Yeah? Now that's all for everything products. What have we not talked about? Quotients. So intro to quotient rule, just like we did with product rule. Intro to quotient rule. I give you a problem and I say, hey, can we solve this using basic rules? Yes. Derive the top and the bottom. No. No, 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 no. Basic rules, there is no division. There's sum and difference, constant multiple, constants, power rules, and of course sine and e to the x, but that's not in this problem. How do we get rid of that division?
To the power of -1.
We could make it x to the power of -1, if that makes sense. And if we multiply, in my head, x to the -1 over x to the -1, these would cancel. And then we can go ahead and just distribute, boom, 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 him in. That's one way. For some of your brains, it might be easier to not think about it as x to the -1, but think about it as 1 over x. Why? What happens down here? Same thing. Same thing. And for just a few of you, maybe the heart method still rings true. Whenever we have a single denominator, we can make each of the terms of the numerator divided by it. But either way, how does that happen? And what are we doing? Rewriting or deriving? Rewriting. We haven't taken any derivatives. We're just like playing with stuff. You might not think it's playing, but whatever it is. So, x cubed over x becomes x squared, right? Because these are all like over 1, if you just think of it that way. Over 1, over 1. X cubed over x is x squared. Minus, what's x over x? 1. Plus, what's 1 over x? Ugh. Why would I write it like that? What do we still need to do? Derive it. F prime of x is equal to 2x, easy, minus 0, easy, minus, bring down the 1, plus a -1. X to the, what's -1 take away 1?
-2.
-2. Is that an answer? Is that a multiple choice answer? Probably not. What would they do? They would say, we had it in fractions to begin with. We want to end in fractions. Is that an answer? Is that a multiple choice answer? Probably not. Because they say it was one big fraction to begin with. We want it to be one big fraction to end. Oh, what are they getting? Common denominators. And we end up with, here's a more probable version of the derivative. But were they all right? Yep. They were. However, what if I was to give you something like this one? Sine of x over x squared. Uh-oh. Can I split that up in pieces? Pass back to Kim. Can I split sine of x over x squared into pieces? Can I split them apart? No. Can I make it x to the negative 2? Yes, and then it'd be a product rule. Let's learn the quotient rule. How do we deal with these quotients? How do we deal with these quotients? You saw this in the separate packet too. I might write it just a little bit differently as well.
The first one?
But ironically, it's going to actually kind of look somewhat similar to the product rule. But what's different so far from what you can tell?
Minus.
It's a minus, not a plus. Product, multiplying. Multiplying usually makes it bigger. Bigger, plus. I don't know, maybe. Quotient, dividing. Dividing makes it smaller. Minus, I don't know. They're so similar, but quotient rule has a minus and. This is the poor little guy that usually gets lost. Either the minus gets lost or the poor little denominator gets lost. Now for product rule, I'd say second d first minus first d second all over second squared. But for a fraction, it doesn't really work that well. So here's what I'm going to do instead. I'm going to say, instead of second, bottom. Why? Because he's on the bottom. Bottom d first, no, not bottom d first. Bottom d top, right? Bottom stays the same, d top, derivative of the top, minus top. How am I going to keep going? D bottom. All over bottom squared. Bottom d top minus top d bottom all over the bottom squared. Just kidding, not the bottom. Shh. Just bottom. Bottom d top minus top d bottom all over bottom squared. Or in rules, we could say the derivative of any quotient would be bottom times the derivative of the top. And by top and bottom, I'm talking about numerators and denominators, just making it sound prettier, right? Or faster, or quicker. The bottom function times the derivative of the top minus the top function times the derivative of the bottom. All over bottom squared. On the page before, we had an option with 1, and we took it, we broke it apart, and we used basic rules, but we didn't have an option with the other. So we're going to use the quotient rule for that nasty sine of x over x squared. You ready? Let's see this quotient rule in action. There we go. Who's the top? Who's the bottom? Just kidding. The bottom. X squared. And how does the derivative work?
Bottom d top.
Bottom stays the same. D top. What's derivative of the top?
Cosine x.
Cosine. Minus quotient rule minus
Top.
top. Keep them. D bottom. Derivative of the bottom is
2x.
all over
Bottom square.
bottom squared. Don't lose any pieces. If I were to rewrite this, x squared cosine x minus the 2x comes in front. Why? Don't kill any poor ostrich, whale, elephant. Why does the 2x have to come in front and it cannot stay next to the sine of x? Is 2x in a sine? We have to keep them separate, yeah? Now what? We're done. Stick it to the man. I would say factor. Can anybody tell why? The x comes out. And not only does the x come out, but what do we have chilling down below? Too many. X times x times x times x. Let's simplify one of those away just to make it better. We have x cosine x minus 2 sine x all over x cubed. Dun 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 dun. Dun dun. So, what would be the only other legal approach to the intro problem that we had? The only other, meaning this one, we can break it apart fairly quickly. But if we were to keep it as a quotient, because the multiple choice answers are all quotients, and we don't want to break it apart and have to put it all back together with common denominators, how would we have to look at this function? Bottom and top. And how would we derive him? You guys, tell me the quotient rule one last time. Derivative of the quotient is bottom d top minus quotient rule.
Top, D bottom.
Top d bottom all over.
Bottom square.
The only thing left to do is simplify. Get out of here, cool kids. You have the product rule. You have the quotient rule, but now you have to master it. Practice in your homework. Come back tomorrow with maybe a few questions. We will go over 2-2b evens and finish 2-3. Bye, guys. 0 period tomorrow. I'll be in here after school with pre-cal as a test. Might not be the best day.
Not today.
Maybe like a little question, but not a lot.
Okay. Can I leave my stuff in here then? So that way I can concentrate.
Totally cool.
Non-credit, so it just like amazing.